and I'll share my screen. So today we are going to do a system design of Uber or Ola or some of these ride sharing apps. We're gonna break down the functionalities of these apps, right, and try to understand how we can figure out a solution together, right? So okay, more people are joining. Okay, let's get started, right? So we do a system design of Uber. Let's try to understand how an app like Uber is going to function, right? There's going to be two people who are involved in something like Uber, right? There's going to be a rider and then there's going to be a driver, right? So I like to think of it starting from the driver, because a rider cannot exist without a driver. So let's start the system design by thinking about the driver first. Okay, so how does it work? A driver onboards on the app, right? Let's just say this is his phone. Okay, so a driver comes on the app, right? He goes to his phone and he registers with Uber. And one of the other things about this lecture is, right now I don't have any idea how Uber is designed. I'm going to design it ad hoc with you people, right? So what I want you guys to understand is how I am thinking, and basically just try to design it together, like you and me together, right? So I'm starting with the driver because, like I said, it's the first point of the app. A driver comes on Uber, right? Comes on Uber, he registers on the app, right? And then he gets an ID or something like that, right? So the first service that I can think of is a driver registration service. Let me just think. We had, yeah, okay, let's just go here, right? So the first service I can think of is a driver registration service. Give me a minute. Yeah. Okay, or authentication service, right? It's the same thing that we discussed, right? Or user service is something we say, right? So let me name it user service for convenience, right? Driver, right? So the driver registers on the app, he gets a user ID, he gets a cab location or something like that, right? And what is some other service that you guys can think of for a driver? Any of you? What is the next service that's coming to your minds? Hello?
Service to get the list of the customers nearby. Discovery service, yeah.
Service to maintain list of customers nearby. I don't think that's the way I would want architecture of Uber to be, because again, there are trade-offs in everything, right? So you are saying that a driver has a service to maintain list of customers nearby, but I ask you this: is a driver searching for customers, or do customers search for drivers? Your voice is not audible. Who said that?
Yeah, the
Ah,
customers,
yeah.
but
Okay,
like the rider must, not rider, but the driver must accept that ride, right? So he
that's
will
a
be finding the
different.
nearest one.
No, that's a different use case, right? When you talk about a service, right? I mean, you thought of that, right? When you talk about a service for a driver to find the near to find to main like, you're basically, when you talk about a service, you're basically maintaining a list of drivers. Uh, like, this is a driver A, and these are the customers nearby to the driver A, right? Why do you think a service like that will be needed?
We cannot randomly assign it, right, to any like driver Any rider cannot pick any of the drivers. It should be whatever is feasible for driver. That would be the one. Right?
Okay, but the customer is not searching at that time. Like, why would I want to maintain a list? Okay, we'll revisit this later, right? But I would say such a service should not be there. But anyways, the way I can think of it is there's a user service for the driver. The other one is the cab location service, right? Now what this cab location service is going to do is it's basically going to maintain a real time location of where the cab is, right? If the cab is active or not, if the right driver has Uber switched on his phone, right? Then that means he's an active person. So just going to write down a definition of what this service is going to do, right? So the cab location service is it checks what it does is it periodically gets the location of the cab, right? So let me think of how the data is going to be in this service, right? Let's just say this is an ID, which is basically the cab ID or the driver ID, right? Unique ID that identifies the driver or the cab. And then it's going to have the latitude, right? And it's going to have the longitude at any given point of time, right? What the latitude of the cab is and what the longitude of the cab is, right? Which basically pinpoints that the cab is at this point at this given point of time. And then what I can think of is latitude, longitude, okay, cab type or something like that. uh, Again, complete metadata, right? Then but basically it's just the location of the cab and is active or not, right? If the driver has Ubered on his phone, switched on, he's actively searching, then it's more then I should give that driver more priority than over someone who does not have Uber on his phone, right? So let's try to design this.
One thing,
Yeah,
uh, the driver can also have a service like, is he available or not right now? Maybe he is already in a drive taking someone, so he will not be available.
exactly, that's why I said is active. Again, yeah, you can have more metadata here, right? If the driver is available or not. Good catch there, good catch there. Is engaged, but we can put it in is active also, right? But so I'll remove it, keep it in is active. But yeah, great catch there, right? But so now when you talk about this table, right, how do you think this cab driver is going to communicate this latitude and longitude, right? From what I can understand is that he's going to periodically, like every minute or something, he's going to broadcast this information, right? So what would be a good protocol for doing this? We just did it yesterday.
WebSocket.
Yeah, exactly.
That
WebSocket, because if you were to do it via HTTP, right? Basically, you need to poll this, right? Which is a like not the right way to do it, right? This HTTP has a lot of issues. WebSocket is easy. That this cab location service is like it's the logically right solution, right? That the cab location service polls the polls here every second, and it finds out, okay, hey, this is your latitude and longitude, right? Instead of this app constantly updating the server, right? We don't want to have the app do too much responsibilities, because when the app is doing a lot of these things like polling the server, maintaining this list, what happens is that whenever you want to change something, right, you need to push a new app version, right? So the app needs to be kept very light. It needs to be just, okay, if the server wants this, you just give it this, right? So doing it, making it like that, it makes the app very light, right? There's most of the responsibility goes to the server. So the server can poll it, it can get its current latitude and longitude is active or not at that given point of time, right? So cab location service is easy. Rider comes on Uber, he registers with the service, he gets a unique UUID, he goes to the cab location. He's periodically getting the cab location at any given point of time, which is being maintained here, right? So from what I can think of is this is a very basic architecture of so the user is registered on the app, his location is being tracked. Right now we get into all the nitty gritties, right? You can have something like how do I say, payment service or something like that. We are not going to go into detail over this service unless you guys want me to over any service, right? Because it's not, because these are again very common services which are used everywhere. So the user wants to, once a rider has booked the cab, right, this cab location service is updated, and then there's this payment service which is basically used for processing the payment. Then we can have something like tracking service, right? Ride track service. Ride track service is basically used for tracking the ride, right? When the rider comes on the app, he books that app. Now this ride track service is basically going to track the ride from the location to the destination, right? So at any given point of time, the rider can, see where the ride is, where the ride is or where he has to go. So this ride track service can expose all kinds of APIs for that, right? So it can directly, let's just say, it can talk to the Google Maps endpoint. There's this Google Maps API, right? So what I can think of is this ride track service is going to basically just be like an overlay wrapper on top of this Google Maps API, right? So it has the, like, it does end to end all those things, right? If you want to like, if the cab is at a given point of time, right, from the cab location service, and the customer is booking something, right? Now uh, some services will be common. This ride track service will also be used by the customer, right? Like, let's just say there is this booking service, right? Booking service, and again, I'm going to come to this service later because it's going to be used by the customer also. So there's this booking service. Let's say he booked a cab, then this ride track service is going to give him the destination. So the rider can pull this service and find out that, okay, this is the point where I have to come. Okay, what is the route for there? It pulls the Google Maps API and it finds that, and once he reaches there, so all kind of map related things can be done by this ride track service, right? And we can have something like a analytic service. What does this analytic service do? This analytic service maintains all the analytics information, right? So let's just say this is a driver, right, and he is going in a certain direction. So that's being mapped, that's being tracked in the ride track service, right? The, because where what is the direction that this rider is going, right? So the analytics service can hook up to this service and see that if he's going in the right direction or not. If he's not going in, then that's an anomalous behavior, right? It can also go to the let's just say there's also a service known as a review service, right? Review, SOS service, review service, or SOS service, right? So it can hook up to all these services and see for behavior. It can also, normally just gather metadata, meta information about the cab, right? uh, so these are all the services that I can think of that the driver is going to need, right? Right from the cab, when he's basically registering with Uber, when he's going, he's going around without booking anything, or when he takes a booking, to when he's, the whole booking is being tracked to the time when he's doing the payments. Everything is covered within these services. Okay, so any questions here to so far, or any ideas that you guys might have? Hello. Okay, then we go to the rider. Okay, now let me think of what are the various services that this rider might have, right? So again, some common services, user service. Okay, I actually wanted to go a bit deeper into some of these services, right? So let's just say this is a cab location service, right? So this service is going to be heavily sharded in nature, right? Why does it need to be heavily sharded? Because this is a write heavy. If you can think of it, the cab is constantly broadcasting its latitude and longitude to this service. So this needs to be heavily sharded. So there's going to be like multiple, small replicas that will exist, right? So we need to shard the writes also enough so that you can write a lot here, right? So the way that I can think of when you're sharding it is that you shard by location, right? Because when you think of a app like Uber, right? So Uber is a pan India app, right? Uber exists for the world, Uber exists for all of India, but it doesn't matter, right? When you're in Kolkata, it doesn't matter to you if there is a Uber in, neighboring cities, or if there's a Uber that exists for a different country also, right? If there is an Uber Kolkata, that is just restricted to, Uber Kolkata or Uber Bangalore, right? You could use that app conveniently. There is no international feature, or there is no pan India feature that you are going to use. So if I have to shard this app, right, I can literally shard it by the data over a location, over a certain location, right? That would make the reads writes extremely fast, right? So whenever I have to shard it, I'm going to shard it by the location, right? So this table is going to be heavily sharded by the location, and there's going to be write and, read replicas, but again, it's as write heavy as it is read heavy, right? And then what are the other services? Okay, so now I come to the user service, right? So the user is the rider. So the rider registers on the apps, he gets a UUID, right? And he goes to the booking service, right? The service that I can think of is price determination service, right? This will tell him whether his cab is going to be for 100 rupees or his cab is going to be for 500 rupees, right? So any idea how this service might be working? Yeah, look, you continue.
Uh, Based on the distance covered between point A and B, I guess calculation will work.
Now there's going to be a lot of metrics to be taken by this service. A, it's how
The
is cab prices, yeah.
Yeah, the traffic probably is one of the metrics. How crowded the location is,
Okay,
something
yeah,
like that.
that could be one of the metrics. The metric I can think of first of all is going to be that how many cabs are in that certain region, right? Now I can think of an idea in which we can determine that how many cabs are in the vicinity of this rider. Let's just say this is a rider, right? He gets a latitude and longitude, right? At any given point of time, he has a latitude and longitude, right? Now let's say the latitude and longitude are lat and long, right? So now what I can do is I can do a for loop that goes from lat minus 1 to lat plus 1, and another for loop that goes from long minus 1 to long plus 1, right? So these are 9 areas, and I see that already in my cab location service I have all these latitudes and longitudes of cabs. So in this squared, right, I see that how many cabs are present, right? So I do this for loop, and whatever cabs I get, those are the total number of cabs, right? And then I figure out the distance from those cabs, right? And then I figured out that okay, I have this many cabs that are available for the person, this is the distance, this is the metric, right? And it's a peak time, whatever time, so there's complicated math going to be there. And so it comes up with that price based on all these metrics, right? And it gives a price to the rider, right? And now when the rider is searching for the price, it's going to broadcast to all those cabs that are present in the region, right? So I can think of a broadcast service. Okay, broadcast service which is going to basically broadcast to all the cabs in the vicinity, right? It's going to send out a push notification or on the app notification to all the users, all the cab riders nearby, that hey, this guy is going to give you is available for servicing, right? Would you like to take up his service? So all of them can let's say select yes, or one of them can select yes, and then he gets the cab, right? So That's how the cab booking works. Then once he selects that cab, right, once a person is selecting, then he basically gets his location, right? And then we go to the right track service, right? Within the right track service, what I can think of how the database will be structured is there could be a ride id is active, is the ride active, like location, current location, destination, right? Price and other metadata stuff is there, right? But maybe price could be other place also, right? There's price calculation could be on his location and destination, but it shows his current start location could also be there, start location. So this ride track service, it's gonna start, right? And his ride is basically active, he gets an OTP. And like for any every other service, right, as a commonality, there's gonna be a notification service, right? So we send out the notification here, right, that he gets, okay, the OTP. When he gives his OTP to the ride track service, the ride is starting, right? He gets the current location, destination once he reaches the destination. And you can also edit now. Again, I'm going to shard this service because, again, as you can understand, that the customer can change his destination also. There's a lot of rides that are happening here, because at any point of time there's 10 million rides that are happening, right? So I'm going to shard it again by the location, right? So if you think about a service like Uber, right, there are big numbers, but those numbers don't make a lot of sense, because like it's a hyper local kind of app, right? So you can shard it by location as much as you want. You can create an Uber for a 20-kilometer radius also, and no one will give a shit, right? Because people are not searching for, locations beyond that. uh, People just want hyper local rides, right? So that's why its system design is not that complicated if you think of it. Obviously optimizing is a challenge, right? So one more thing, if you look at, but again, here also it's gonna give this location. When you reach your destination, it's gonna hit the payment service, and you're gonna do the payment, right? And then it's basically just going to process the payment the way it does. The way how you can optimize Uber, right? Because when you think of it, the major cost that is incurred with Uber is when you're going to determine the prices, right? It hits the Google Maps API, because it directly, the price is directly correlated with things like, what is the location to destination, and what is this, that, right? So Google Maps API is costly. You need to figure out that what is the traffic at any given point of time, and what all are happening, right?
Yeah, so like something creating a inbuilt map service,
Exactly,
maybe with this.
exactly.
Like I read today, like Ola did this, I think so.
Yeah,
Like
yeah. So Ola did their map service, right? But if you look at it, there are companies that are nowhere near the scale of Ola, or nowhere at the scale to operate a map service, who are also doing that, right? So what you can do this is a Google Maps API cache, right? The way I like to think of it, or I am thinking of it, is a Google Maps API cache that can exist. So let's just say you're in Bangalore, right? You are trying to book a service from, let's just say, MG Road to Kodmangla, okay? You have a friend who is booking a cab close to MG Road to some location that is close to Kodmangla, right? Let's say Belandur or something like that. So when you are polling Google Maps, right, you already know some of these parameters. You already know how much the traffic is going to be on the route between MG Road to Kodmangla if there is a highway, right? You know how much traffic. You have already polled Google Map once, and you have figured out that this is the amount of traffic, real time traffic, that's going to be on the highway. That this is all the metrics, right? So you have already pulled Google Maps once. So what you can do is you can take this route, right? Take this route that you have fetched Google Maps once, and you have fetched out the traffic on the route. You have fetched a lot of parameters on this route. You can figure out a caching mechanism for this. You can figure out that, okay, this is the route, and I'm going to So this part is common because you figured out how much traffic is going to be there, right? So that way you split it between highways, you split it into small chunks, right? Small distance chunks, and you come up with your own algorithm that can, you know, make up a price. And that way, instead of doing million calls to Google Maps, right, for each and every, you're doing 5 calls to Google Maps. So while the customer is not paying anything, you end up paying a lot of money. So you cache it all, right? You cache it all. You make sure that for a given highway, for a given route, at a given point of time, maybe in 10 minutes, I'm only calling Google Maps once, right? So this is the way that you can cache this, and this is the major cost. If you optimize on this cost, you have optimized on a lot of things, right? That's why Ola came up with their own service right now. Right, so this is kind of a very basic overview of the system design of Uber, right? How would you want me to, you know, deep dive into this? What else would you want from this service?
I can think of one more. Like there is something pool ride service, like multiple riders come in the same car. How
Definitely.
would that be handled?
So Uber, I don't think, provides pool ride service, but if you want to do something like a pool ride service, you can always do it like this logic that we did, right? So if A and B both are riders and they're booking their cab from this location to this location at a given point of time, right? So you can see his latitude for booking is X and Y, right? Rider two's latitude for baking is A and B. Let's say this is AB, this is CD, right? So you can figure out the distance between AB and CD, right? You can what you can do is, one more idea you can do is, you have this area as Bangalore, right? So what you can do is you can break it into squares. Okay, you can break it into this grid, and you know, there is a mic into like microgrids, right? And then there are people who are traveling from microgrid A to microgrid Z, right? You connect all those people who are traveling at any point of time from microgrid A to microgrid Z, right? That's one way to do this thing. The other way is, you have a cab direction that is fixed, right? There's a cab that is traveling like this, and it touches on the microgrid A, it ends right somewhere in the microgrid Z. So when this cab is traveling, right, you see that all the cabs that are going in this route, right, you can alert those drivers that, hey, along this time this cab is going to come from here, and it's going to, when it's leaving, it will touch your microgrid, right? So that's one way you can handle pool, right? It's not a very complicated problem to handle, right?
Hmm, got it.
Yeah, what else can you think of?
A service
That
that handles cancellation of rides.
Cancellation is not that difficult, right? So the way that booking service is handling booking of rides, you can handle cancellation. It can be linked to a fraud service that checks that, you know, if the rider is already in the ride, has he cancelling the ride or not. It can backfeed into some service, right? The feedback service or something like that, that, you know, if after the cab is booked, if the driver is cancelling. But again, cancellation is not that difficult of a challenge, right? You can just have a cancel endpoint here for canceling. What else are you thinking of? Slash cancel for canceling, slash book for booking, right? User service, cab location. Yeah, I think we pretty much covered everything here, right? Hello.
can we discuss something on SOS service?
Sure,
Like
sure.
how
It's a simple service from what I can think of. If someone you can make it like a smart SOS service, right? So you have the routes, right? And you know, these are routes where people are not traveling that frequently, right? So if a rider is going on that route, you can have it alert the SOS service, right? Then again, when you think of it, right, the other thing is someone can directly trigger the SOS service, right? slash SOS that alerts the rider, right? Yeah, you can also have certain parameters where anomalies can happen, and that can traverse that SOS service, right? Let's think of something else. Like, I'm thinking of, if someone wants to know like what are the architecture, right? So all the riders at any given point of time send out a request, right? And that request goes into, let's say, a message queue, right? Queue, sorry, message queue or Kafka, right? So all the write requests go in here, and then they are picked up. So what happens at the peak times, right, when there are a lot of people, like, at 4 p.m. in Bangalore, everyone's trying to book their cab, right? So the rides go out here, right, and then they are picked up by the booking service, which basically starts the booking process, right? It or the broadcast service, right? It hits the broadcast service, and that sees the nearby cabs out there, and then it's gonna send that request out to that cab, that please book my cab, right? uh, One of the ways I can think of optimizing the price determination service is again the same thing, right? Determining the uh, if I am someone who is searching at that given point of time and someone else is searching, then I don't need all those parameters again, right? People near the same location could be grouped and formed a cohort, and that can help determine lower the price of the that can help figure out that, okay, this guy is booking a cab for a same location, and 4 kilometer away, similar traffic, this other guy is also booking a similar location, so we show them the same price, right? And then the rider puts that in Kafka, right? And one other place where I can think of a message you can go is when the rider is broadcasting his location to the cab location service, right? So what I can think of is that the messages that are being broadcast, right? um, let's remove WebSocket here and think of that the app itself is sending this location to the driver periodically, right? uh, Trade-offs, there are bad parts in this thing about this approach is basically that you don't know the location when the driver is switching off his phone. You don't know where he is, so if you're going to send him a push notification, he might be at a completely different location. But if you're thinking of it that a lot of cabs are broadcasting their location to this cab location service, you can think of having a message queue when it's HTTP protocol, right? So a lot of those cabs are a lot of those phones are broadcasting their location, and that's protecting it from any kind of issues, right? So what you can do is put them there with a TTL of, let's say, 1 second. If every second you're broadcasting, whereas the next second it's useless, that location is useless, the rider has moved on. Okay, so I can't think of anything else. I think we pretty much covered everything, right? So tell me, you guys tell me if there is anything you want to dive deeper into. Hello.
Yeah, Ramit, this ride track service and cab location service, isn't that like till both they are on different location, it's okay. But once they are like ride is started, that would be same service as cab location, right? I mean,
Yeah. So the way I think of the ride track services, it's basically tracking the it's not just tracking the location of the cab. It's let's just say it's tracking some other metadata also. It's for active ride, right? It, like, when the rider has actually booked the cab, right? So you need this service to be a lot more have more effective writes and reads as compared to something like a cab location service, which is the location of cab, right? But this is an actual ride that's going on. The rider needs to know at any point of time where he is and what is his location. So let's say this service is being used by 100 cabs at a time. This service will be used by 10,000 cabs at a time. So when you are building a real life system, right, you need to segregate these two, because this might go down, right? And useless people will be like, the people that are not that much concerned will be affected, but if this goes down, it's an issue, right? And so you want to separate this, you want to keep this at low traffic because it's being used by people on active cab rides, right? So that's why I've separated it. Yeah.
And how are we going to match like rider driver? Are we going to match it, and like who is going to accept whose
Yeah.
request in the?
Exactly, like I already stated, we have this broadcast service, right? So whenever a rider comes on the platform, he goes to the price determination service, right? And I already explained this cohort thing. So he's going to figure out a price, and then what he's going to do is all the cabs that are in the vicinity, right? And how do you find out vicinity? Using this formula that I said, latitude -1 to lat +1, long -1 to long +1. This for this square, whoever is there, he's going to broadcast his price like an ad to all of those riders, and once one of them accepts it, he is going to be assigned to that rider. Then that details will be fulfilled in the ride track service, and they can see that, okay, this is where I have to go. And basically this rider and driver will now basically just interact with this ride track service to figure out where they are and where they have to be, right?
Got it.
Yeah. Okay, I think this is good. We had a great discussion on Uber, and I think you guys should be able to do this. So, Uber, Ola, and whatever platform is. So, I think as we are doing more and more discussion, it gets a bit clearer, like how to design these systems, right? So, we'll have a short Q&A now, right? Uh, any questions